Hi guys, so in this video we'll talk about another very commonly asked HFT interview question, which is implement your own unique PTR in C++. So before jumping into the solution, let me give you a bit of a background at why smart pointers were introduced in C++ and what kind of problems programmers used to face before the creation of smart pointers and how they used to deal with them, and why eventually smart pointers were introduced and what kind of use cases they solve. So like unique PTR, shared PTR, weak PTR, they are all smart pointers. So let's see. So let's imagine that there is this function f which takes 3 arguments. It allocates some memory on heap using this new operator, and it has like very deep nesting where there are multiple early return statements, multiple places where you could throw exceptions based on the values of arguments which you have received. Okay, so in every return path or every path where you are throwing exception, you have to make sure that you deallocate this memory which was allocated on heap, otherwise there will be memory leak. So this is the programmer's responsibility. So he has to make sure that he delete this PTR before returning here, he delete the PTR before throwing the exception, and also eventually at the end of the function to delete this pointer. So you can see like this is actually problematic, because let's say in future someone adds another branching here, okay, and there might be a return statement or a throwing exception statement here, and if the programmer forgets to delete the pointer there, so there will be memory leak. Okay, and another thing is that let's say someone removes this return statement at some point in future but forgets to remove this delete pointer. So what will happen, that the control will eventually come here and this pointer will be deleted twice. So double deletion is actually undefined behavior in C++, and it can lead to program crashes, and these are very hard to debug as well. So these were the problems which used to exist. Like it was the programmer's responsibility to deallocate the memory which he has allocated, and also to make sure that that memory is deallocated only once, not twice. And so for solving these kind of problems, like eventually smart pointers were introduced. Like if you take example of programming languages like Java and Python, they do not have this problem because they have garbage collected languages. Like garbage collector takes care of deallocating the memory which has gone out of scope. But in C++, it was programmer's responsibility. Again, like garbage collected languages have some of their own inherent problems, like they can cause program slowness and all. But again, so what C++ decided to do, that they introduced smart pointer. So there the driving force behind that was that you allocate the memory in smart pointer, like whenever you are allocating memory, like it will be owned by the smart pointer, and eventually when the smart pointer will go out of scope, like let's say I would have allocated this, basically I have given this the ownership of this pointer to, let's say, my unique PTR. Okay, so whenever this using this, like you can give the ownership using this. I've called the constructor here, sorry, this should be pointer. So at the, like whenever this function ends, like this function can end here where we are doing an early return, or here where we are throwing the exception. So this unique PTR is a local member of this function, and eventually this will go out of scope, and since it will go out of scope, its destructor will be called, and in its destructor this pointer will be deleted. So now programmer doesn't have to worry about deleting this pointer at every path of the program where this function can terminate. Like it will be taken care of automatically in the destructor of unique PTR. So this was the reason why smart pointers were introduced. So let's see like how unique PTR are implemented. So as I said, like in C++ 11, 3 smart pointers were introduced: unique PTR, std unique PTR, std shared PTR, std weak PTR. All of these 3 smart pointers are defined in the memory header. I mean, you have to hash include this memory header if you want to use any of these. So each of those 3 smart pointers have their own use case and have like provide their own features. So let's see what unique PTR does. So from CPP reference, like the formal definition for unique PTR is that it is a smart pointer that owns and manages another object through a pointer and disposes of that object when the unique PTR goes out of scope. The object is disposed of using the associated deleter when either of the following happens. So basically the memory will be deallocated when either of these 2 things happen. The first is that the managing unique PTR object is destroyed, or the managing unique PTR object is assigned another pointer via operator equal to, which is the move assignment operator or reset method. So in case you didn't understand these formal definitions, so I'll explain you, like as we'll go further in this video, we'll look at the implementation, these things will become clear. So let's see. So as I said, like for example, we have this int main function. Okay, here you have allocated an integer pointer. Now you have to make sure that this is deallocated as well. So what you can do is that you can give the ownership of this pointer to this unique PTR instance, So what happens in the background, like this is a memory location where this I is present and this unique PTR is actually pointing to it. So at the end of this main function, this local variable UPTR will go out of scope, its destructor will be called, and eventually this IPTR will be deleted. Okay, so this is what happens. So another thing to remember is that unique PTR is only a move only type in C++. Like it can only be moved, it cannot be copied. Like, unique PTR is not a copyable type. So what does that mean is that it basically means that if you do, let's say this, you had this UPTR here, okay, std unique PTR, and let's say you created another instance of unique PTR which is UPTR2, and you do this assignment. So this will actually fail. This will be a compile error, and I can show you why it will be a compile error. One second. Yeah. So as I said, like what I am doing here is this, that I have this unique PTR UI, and I am basically assigning this U to this new unique PTR. So if I run this program, it should be a compile error. So you can see here, and it says that use of deleted function. This is the copy constructor. So basically the copy constructor of unique PTR, you can see here that unique PTR, this copy constructor is actually deleted. So unique PTRs are only move only type, they are not copyable type. So whenever you are moving the object, you have to do std move. So that move assignment operator or move constructor is called. So anyways, as I said, that unique PTR has exclusive ownership. So when I am doing this, so my earlier use, the way this UPTR existed was this UPTR actually pointed to this memory where this I was allocated. When you do this, that you move this UPTR to UPTR2, so what will happen is this UPTR will become null, and now this UPTR2 will start pointing to I. Okay, so this is what moving type means, or this is what exclusive ownership means, that only one unique PTR instance can point to one this memory location which has been allocated to heap. Basically this is what exclusive ownership means, that the ownership has been moved from UPTR to UPTR2. Okay, so I think let's now look at the implementation of unique PTR, like how you would implement your unique pointer. So this is our unique PTR class, which is actually a templated class. Okay, so this is templated because it should be able to handle, basically it should be able to hold any pointer type. It can be int, it can be string, it can be anything, a custom class, anything. Okay, so it has only one member variable, which is the pointer, which it will be holding, which is t star PTR. Initially it is initialized to null pointer. So these are public methods. So this is the default constructor where we initialize pointer to null PTR. This is a parameterized constructor, like if you pass any kind of pointer to it, any type of pointer to it, so our member variable pointer will actually point to this. So that's what was happening when we had called this, that when we were doing this, this was our integer pointer, and we had passed this integer pointer to this UPTR. So this parameterized constructor is called, where this pointer, our member variable underscore PTR, takes ownership of this. So as I said, move unique PTR is only a move only type, so its copy constructor is deleted, which we saw here as well, that in C++ the copy constructor of unique PTR is deleted. And so you might think that why copy constructor is deleted, because actually one thing is that there is another shared PTR is actually the one smart pointer which you should use if you want to, you know, copy the things. But another thing is that if you are copying the pointer, so there is an inherent problem. The problem is that, as I said, in the destructor the memory is deallocated. Okay, so if you have copied the pointer to two unique pointer instances, so that memory might be deleted twice. And as I said, like double deletion, basically deleting something more than once, is actually undefined behavior and causes program crashes. So for that thing, C++ decided to make unique PTR a move only type, like it has only exclusive ownership, that basically to one memory location which has been allocated, only one unique PTR instance can point to it, not more than one can point to it. Okay, and again, like if you want to copy things around, so std shared PTR is the one you should use, and we will talk about that as well in a later video, how std shared PTR makes sure that the memory is deleted only once, not more than once, because as I said, if you're copying, there is a risk of deleting that memory more than once. Anyways, back to our original problem. So as I said, the copy constructor is deleted. This is our move constructor. Okay, so you can identify move constructor by seeing this, that it has double ampersand. So in move constructor, what we are doing is that we are initializing our underscore PTR to this, like whatever is returned by the release method of unique PTR. So we are calling this release on right. So let's see what release method does. So release, here is our release method. So what it does is that it will copy the pointer to which we were pointing in this old PTR instance. It will like our unique PTR will start pointing to null PTR, and it will return the old PTR, which was basically the old pointer to which our unique PTR was pointing. So what happened is this, that here the move constructor was invoked. Okay, so what happened here, that we called release on this UPTR. So what did release do? It copied the pointer, which is I, to which it was pointing in an old PTR, and now UPTR is pointing to null PTR, and it returned this I, so that this UPTR2 started pointing to this I. So that's what happened. Okay, in our release we return the old pointer and we start pointing to null PTR, and if you see here, whatever is being returned becomes basically our pointer is initialized to that. Okay, so this is what this thing does. This is that the move constructor does. We can ignore this one for now. We'll see why we have created this move constructor. Now in destructor, what we are doing is basically we are calling the reset method. So let's see what reset does. So reset, like the default argument of reset is null PTR. So we were not providing any argument. So this new PTR will be null PTR. What we do is that we get the old PTR using this release method. Okay, so our pointer starts pointing to null PTR, and the old pointer to which we were pointing is returned here. Now this pointer becomes new PTR. So this new PTR was null PTR only, because in delete in the destructor we were not passing any argument. So new PTR is default initialized, which is null PTR, and if the old pointer to which we were pointing is not null PTR, we delete it. So here we are making sure that we do the deletion only once. Anyways, so that's what destructor does. So basically destructor deallocates the memory with whatever was allocated. Again, as I said, unique PTR is not copyable, so the copy assignment operator is deleted. Here is our move assignment operator. So what move assignment operator is doing is that it is resetting. It is calling reset with the argument, where the argument is basically this, that whatever pointer is returned by calling release on this right unique PTR, and we eventually return this only. So as I said, what would this release do is that it will return to the pointer to which right was pointing, and now right will start pointing to null PTR. And in reset, what we were doing is that our new PTR, that is underscore PTR, will start pointing to this, and to whatever we were pointing earlier will be deleted. Okay, so here you can see that we are making sure that no memory is leaked. Okay, because to whatever I was pointing earlier is now deleted. As you can see here, I got the old PTR using release, and my pointer starts pointing to this new PTR, and I delete whatever I was pointing to earlier. Okay, so that's what this reset is making sure. And now to what I am pointing to whatever right was pointing to earlier. So this get method is exposed by unique PTR, so that does nothing, it just returns the underlying pointer. Now unique PTR, like it is like a replacement for pointers, raw pointers. Okay, so whatever functions you are able to call on pointer, or like whatever syntaxes you are able to create with pointers, you should be able to create with unique PTR as well. So that's why, like, you can basically you can have this arrow operators on pointers. So we have to define the arrow operator for unique PTR as well. So this is what I have done. We have defined arrow operator, and it does nothing, it just returns the underlying pointer. We can dereference raw pointers, so we should be able to dereference unique PTR as well. So that's what we are doing here. This dereference operator takes care of that we are dereferencing the underlying pointer. Release method, I already explained you that what it does, it basically takes the old point, it basically returns the old pointer to whatever we were pointing, and now we start pointing to null PTR. And reset does nothing, it receives a new pointer, like, and to whatever we were pointing earlier will be deleted, and now we will start pointing to this new pointer. There is this swap function where you can swap the underlying pointers of two unique PTR. Okay, so that's what we are doing. Like to whatever to whatever pointer the other was pointing to, we start pointing to that, and now other will start pointing to our pointer. And this bool operator is defined so that basically you can write sentences like this. Like if you want to check if unique PTR is pointing to null PTR or not, so instead of writing this unique PTR dot get is equal to null PTR, you could simply write this, that if let's say unique PTR, so this means that this is not a null PTR. Okay, so this method is exposed for basically programmers' ease of checking whether UPTR is null PTR or not. So let's see how the usage of our class. So here I have created a class A which counts the number of objects which have been created, and this int mynum will take care of which object, like the count of this particular object, the index of this particular object. Okay, so what we are doing in constructor is that we are assigning this mynum to this plus plus object, and we eventually print that this is the object which is being created, and at the point of destruction also we print that this is the object being destructed. Okay, so here what I have done is that I have created a object. I have allocated memory for this. Now our unique PTR will start pointing to this A object A1, and now I create another object A2, and now I reset my unique PTR to point to A2. So what will happen is this, that a constructor will be called here, and now our unique PTR is pointing to A1. Now we create another object, so constructor for A2 will be called here, and now we are resetting. So in reset what will happen is that A1 will be deleted because this was the old pointer, and we will now start pointing to A2. Okay, and then we are exiting main. So when we are exiting main, the UPTR goes out of scope, so A2 should also be deleted. So if I run this, we will get this output only. If you see here, what happened that we constructed A1 which was constructed here. Okay, then we constructed A2 which was constructed here, constructed object number 2. Then we are doing reset. So in reset we will destruct the object number 1 to which we were pointing earlier, that is A1 is destructed. Then we are exiting main, and since we are exiting main, UPTR will go out of scope, so we are destructing object number 2, that is A2. Okay, now another use case. So one thing is that with pointers, as I said, like whatever we can do with pointers, raw pointers, we should be able to do with unique PTRs as well. So you know that a pointer of base class type can actually point to derived class as well. Okay, so let's say this was a base class and this is our derived class which is derived from base class. So this syntax is actually valid. So this syntax should be valid with unique PTR as well. So how we have taken care of that is like this, is our, so we should be able to write this like this is a unique PTR which is of type base, resource base, and this is our derived class resource. So we should be able to initialize the UPTR of base type with derived class type. Okay, so to support this kind of syntax, we need those two templates which I had shown you earlier. So this general template is required, like you accept any type of pointer that is unique PTR u and then write, and then you eventually initialize your pointer to write.release, and same syntax need to be supported for this as well, move assignment operator. Okay, sorry, this is that. So this template parameter, you can see this u is actually different from the template parameter of this unique PTR class t. Okay, so that makes sure that any type u, so don't think that any type of u will be able to be basically assigned to this PTR which is type of t. Like you cannot do something like this. I mean, with pointers you actually cannot do something like this, that if you have int star PTR, you cannot initialize it to double. Okay, similarly you should not be able to do this with unique PTR as well. So this actually will make sure of this, because like these templates will make sure of this particular use case that we are not doing this, because like when this u will be converted to t, at that time you will get the compile time error. So anyways, I think that was mostly it for this particular video. Another thing which I want to highlight is that you actually should never create unique PTRs like this, like you are initializing up, you are allocating memory on heap and you have this pointer, then you are passing this pointer to UPTR. You should actually always use the std make unique method. Okay, you can read about this on CPV reference. And if you want to see the implementation of GCC for unique PTR, here is the link which you can visit. It has the entire implementation of std unique PTR. So like in C++, there are two things, like this is a normal unique PTR which accepts pointer of any type for single objects basically, and then there is a different implementation for unique PTR which accepts like array types, because for arrays you need to delete, you cannot delete the memory using the delete operator, you have to use the other operator. That is like for array you cannot write this, you have to use this particular delete operator. Okay, so that's why unique PTR is differently implemented for arrays and for single objects. So I think that was it for this particular video. Thank you guys for watching. Please do not forget to like, subscribe, and I'll see you all next time.